All right, y'all. My name is Ian, and I am back with y'all to show another problem tutorial. I'm going to be going over problem number 7 from the team round. Problem number 7 reads, let P, Q, and R be positive whole numbers with R not divisible by the square of any prime. Given that P minus Q times the square root of R is less than or equal to 0.01, and Q squared times R is equal to P squared minus 1, what is the smallest possible value of P? So first of all, since we want to think about P, we're going to want to put one of these equations in terms of P and only P. And you should notice that Q squared R, the square root of Q squared times R is going to be Q times the square root of R. So we can rewrite this inequality as P minus the square root of P squared minus 1 is less than or equal to 0.01. Or if we rearrange things so that the P terms are positive, we get P minus 0.01 is less than or equal to the square root of P squared minus 1. And you should notice that since P is a positive whole number, P minus 0.01 also has to be positive, and the square root of P squared minus 1 is going to be non-negative. So since we know that both of these are not negative numbers, we will be able to square both sides of this inequality without having to switch the direction of the inequality. So when we square both sides, we're going to get P squared minus 1 on the right side, and P squared minus 0.02P plus 0.0001 on the left side, and that is less than P squared minus 1. The first thing you should notice is that we have a P squared on both sides, so we can subtract a P squared from both sides, and that'll cancel out. And then we can rearrange to make it that so that the P term is positive, and we can get it alone on the right side of this equation, making the left side 1.0001 is less than or equal to 0.02 P. You should notice that 0.02 is a 50th of 1, so multiplying both sides by 50 is going to turn this 0.02 P into just P. So we'll get that P is greater than or equal to 1.0001 times 50 is going to be 50.005. So if P is greater than or equal to 50.005, and we know that P is a positive whole number, then the smallest possible value for P is 51. And we first also need to make sure that this Q squared R can be set equal to P squared minus 1, such that P minus Q times the square root of R is less than or equal to 0.01. But you should notice that for any whole number, we can write its factors as Q squared times R, where R is not divisible by the square of any prime. We can do that by taking all of the prime factorization of that number, in this case, P squared minus 1. And for all of the prime factors that do have a matching pair, they will be factors of Q. And for the prime factors that do not have a matching pair, they will be factors of R. For example, if we were to take the number 48, where the factorization is 2 to the power of 4 times 3, then Q would be equal to 2 squared, and R would be equal to 3. That's just an example, and you can test it yourself to see that every single whole positive number can be written in the form q squared times r, where r is not divisible by the square of any prime. So since that will work no matter what p squared minus 1 is, we can find a value for that will satisfy when p is equal to 51. So the smallest possible value of p is going to be 51. And we're done. Thank you.
This is Tim. Hope you're enjoying our videos. If so, you know what to do: like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.